So this week, we're going to take a look at two sections, 9.4 and 10.1. Okay, 9.4 is on what we call conics, and 10.1 is something I think you've done before, solving systems. We've done 2 variable systems. We're just going to do a review of 3 variable systems with elimination and substitution. So Thursday will probably be the easiest day this week. All right, so when we are looking at conic sections, we're studying 4 different shapes. Okay, and these are the 4 different conic sections that we study. What a conic section is think of it as like a cross section. If you took a cone and you cut it different ways. Okay, if you took a cone and you cut it perpendicular to its base, parallel to its base, you would get a circle. If you cut the cone instead of parallel to the base but at an angle, but still when you cut it go through the sides of the cone, then you'd get more of an oval shape. We call that an ellipse. Now if you take a cone and you cut it at an angle, but instead of going through the sides, one of the cuts goes right through the bottom of the cone, the cross section you would get is a parabola. And the hyperbola, that one's a little bit different. That is a cut that is perpendicular to the base. But it's like you have to put 2 cones together and slice it straight down and then look at the shape that you create on the edges when you make that cut. Okay, that's a hyperbola. Right, so that rectangular plane is representing the cut that you would make through the cone. And the hyperbola is the only one you have to put 2 cones kind of back to back to make that happen. Okay, any questions on those 4 shapes or how you get them from a cone? So what we'll do, something very similar with each shape. We'll practice doing some graphs and then writing some equations. Sometimes I'll give you some information, like I'll tell you some characteristics of a parabola, and then I'll say, okay, what would the equation be? Or I might give you some characteristics and say, what would the graph be? Or I'll give you the graph and I'll say, you tell me all the characteristics. Each one of these shapes has different characteristics that define it. Parabolas are a little bit different than all the other ones. So we'll do parabolas first, but then circles, ellipses, and hyperbolas, they're all very similar. Okay, the kinds of things that you described. Okay, and the equations, they're also very similar. All right, so let's start with a parabola. All right, so first of all, every conic section is 2-dimensional. Okay, conic sections are all flat shapes. And every definition of a conic section is going to start out with a collection of points in the plane that, and then satisfies some condition. So a circle is probably the one that you're the most familiar with. It's a collection of points in the plane that are all equidistant from a single point we call the center. That's the definition of a circle. Well, a parabola is a collection of points in the plane that are equidistant from 2 things. They're equidistant from a special point F, which we're going to call focus in a minute, and from a special line that you can draw, and we're going to call that line D, which is going to stand for directrix. So a parabola is a collection of points on a curve, basically, that are equidistant from a special point called the focus and a special line called the directrix. Okay, and I'm going to show that to you as a picture, and I think if that doesn't make sense, hopefully the picture will make a little more sense. And I'll put that right back up. All right. So in our diagram, this point right here that I just clicked on, that is called the focus. Yes, I know I didn't use the letter F, but it's just the way the program did it. So that point is called the focus, and line DE that I just clicked on, that is called the directrix. So one thing to understand about the directrix is it never touches the parabola. The parabola always bends away from it. Now, what I'm going to do is I'm going to move point B, and as I move it along the curve in purple, I'm going to continually measure the distance from A to B, which is the focus to the point that I'm moving, and from the point that I have on the parabola, straight up to the directrix. So let me start to move it, and you'll see me measure it with these two things right here. Okay, those things that I just clicked on, they're not fixed. They will change as I drag the point. So let's do this. So as I drag that point, I'm going to continue to measure the distance from A to B and B to C. Those two line segments always come out the same. And if that's true, it means you have a shape that's a parabola. Now, where do you think the shortest distance would be? How could I make those two line segments as short as possible? Now they're 13.6. They've gotten bigger. Where do you think point B would be? Yep.
At the local maximum of the parabola.
Yeah, it would be right at the maximum. Okay, if you take that point, perfect. Put it right, I don't know if I get it exact, but right about there. That's the shortest that you could possibly make it. And when you do that, notice that this maximum is exactly halfway between this line and A, right? If you look at the vertical distance. So that's something we can use. That's a piece of information that if I tell you something about this line and I tell you something about this focus, you know that the maximum is always halfway between the two. And what do we call the maximum or the minimum in a parabola? It's the what of the parabola? Remember, it begins with a V? Yeah, vertex. The vertex. So that's the word we're going to use. So when we start talking about parabolas, vertex is one thing we're going to want to mention. Focus, directrix. So let's go through those different terms, make sure we know what they all mean. Okay, so F, that's that special point, and that stands for focus. And D is a line that stands for directrix. Okay, and in a parabola shape, the focus is it's kind of an important point. If you have what's called a parabolic reflector, right? Like a lot of headlights in cars have this. That means that the shape of the reflective material in the headlight is shaped like a parabola. Might be something like that. And a lot of times when you look at a headlight in a car, you're not looking directly at the bulb. The bulb might be right here. But there might be some kind of cover over the front half of it. And what that does is when you have a light bulb right at the focus in a parabolic shaped reflector, the light will bounce out, hit the reflector, and always go out in parallel rays, just like this. Bless you. Bless you. Okay, so no matter how it hits from that light bulb, all the rays go straight out. Now, if you had a reflector that was flat, that wouldn't work. Like if you put, if you take a light bulb and just put it in front of a flat mirror, it kind of sends the light in every direction, right? It's not going to send the light in straight rays. And when you have a car, that's what you want. You want the light to be reflected straight out. Okay? That's why the front half of that light bulb is blocked. So any light that hits the front, it just bounces right off and goes back out. Okay. All right. Any questions? You might see the same kind of shape with another object, with houses. Anybody think about an object you see sometimes at people's houses that has something kind of at this spot right here, and then this curve around that spot? A lot of people use these at their house. Yeah?
Like a seam?
Like a what?
Like a sink, or are we talking about like a sink? Like water comes down to the bowl.
Oh, like a sink. Oh, okay. Yeah, I don't know if sinks are that curved. I mean, some of them might be. Yeah, some of them might be that curved. But I'm thinking of something, this would be outside your house. Yeah.
Like a satellite dish?
Yeah, a satellite dish kind of works the same way, but it's kind of in reverse. What happens with a satellite dish is the signal doesn't come from inside the dish. The signal, comes from satellites up here. It bounces the rays down into the dish, and then they're all reflected right at a point right there in the dish. And usually there's some kind of, I don't know what they call it, like an antenna or something there in the middle of the dish, and then that sends the signal into your house. So a lot of satellite dishes are shaped like parabolas to gather all the rays and focus them at a single point, and then the wire goes to your house. All right, so this is basically describing the definition of a parabola, but it's just shortening that whole long sentence into an equation. D stands for distance. So let me put that up at the same time as the definition. If you measure the distance from the focus to any point, and then you measure the distance from the directrix to any point, those two distances will always come out the same. Okay, so right now in this picture, they're both 3. I think earlier when I dragged it over, they were like 13, 14, 15. They were getting bigger. But these two numbers always will be exactly the same on a parabola. That's just a shorter way to say it. And if you look at the textbook for this material, they draw a diagram kind of like I did, and it's figure 3. So that's just from the textbook. Okay. Another important line that we talk about with parabolas is the axis of symmetry. So the axis of symmetry formally is defined as a line through the focus and perpendicular to the directrix. So if I take my headlight or satellite dish, however you want to look at it, the directrix should be over here. And if I drew this properly, the distance from here to here should be exactly the same as there to there. All right. Now, if I continue that green line, just make it dotted, that blue line, that is the axis of symmetry. It's perpendicular to the directrix, and it goes through the focus. If you look at where the axis of symmetry crosses the parabola, that's this point right here, that point is the vertex. It's where the axis of symmetry intersects the parabola. And when we draw parabolas, there's 4 different ways we can draw them. We will never draw a parabola on an angle. It's either going to be facing right, left, up, or down. Those are the 4 orientations that we'll draw parabolas in. But you definitely could have a parabola at an angle too. We don't. And then if I asked you what the lattice distance is, or what they call the lattice rectum distance, how they came up with that, but it's basically the width across the parabola through the focus, just like that dotted line. Because there is no fixed width. The parabola is constantly getting wider the further you go. But if you do want to measure one particular point for the width, sometimes they measure it through the focus, and they call that the lattice distance. So axes of symmetry and vertices, that's something we'll see again when we talk about circles, ellipses, and hyperbolas. This lattice distance, the directrix, those are things that are only particular to parabolas. They will not come up again this week. Okay, so each conic section kind of has its own characteristics and traits that we talk about when we study that section. All right, so we're going to have 4 different equations for parabolas, opening left, right, up, and down. We're going to start out with the equation where the vertex is at the origin. Later today, we will shift it. Okay, but we're going to start out with not shifting it, and then if we can get that down pretty well, shifting it's pretty straightforward. Okay, so vertex is going to be at the origin. We're going to have the focus be on the positive x-axis. Now, that should be enough information to tell you which way it's going to open. So think about a parabola where the vertex is at the origin and the focus is on the positive x-axis. Which way does that parabola have to open? Yeah?
To the right.
It has to open to the right. Okay, the vertex always wraps around the focus. So if it's going to wrap around it, it's got to do something like this. Okay, so vertex at the origin. This time we're going to look at where the focus is on the positive x-axis. So you can just draw the picture I have over here. The coordinate of the focus, let me write that down right here. This point would be A, comma, 0. A is the letter that we're going to use when we talk about the focus. Now, the directrix would be right here. What would be the equation for that directrix? We should know what that equation would be based on those distances. Yeah? So I'm looking for an equation, so something with an equal sign. That would be like that would be a single point on the directrix. I'm looking for the equation of the whole directrix. X equals negative a. Yep. That is the equation of the directrix. It's a vertical line, a units in the opposite direction of the focus. So x equals negative a. Yep. And the vertex is 0, 0 for now. Okay, so I talked about what I wanted to there. So let's go to this. So this is the equation of a parabola with the vertex at the origin, and the focus is a, comma, 0. It's y squared equals 4ax. So generally what you have to do is you have to figure out what a is, either from a picture or from information that I give you. A is always a positive number. Kind of think of A as a distance. It's the distance from the vertex to the focus, and distance can't be negative. Now, you can manipulate that. If you wanted to type this into the calculator, you can't type it in with y squared. You'd have to solve it for y. So I'm going to show you different ways you can write your final answer. But this is always going to be the equation that we use as we're working through a problem. Okay, so one thing that can help us when we're graphing a parabola is we know it's symmetric. So if we draw half of it, then we automatically have the other half. So 3 points is usually enough information to sketch the parabola. If you want to go with 5, you could do 5, but for our purposes, 3 is okay. Okay. So things you want to find when you're graphing a parabola: the focus. First, understand that the focus is not a point on the parabola. The parabola wraps around the focus. Directrix, again, something else that is not going through the parabola, it's just bending away from it. Vertex. Vertex is an actual point on the parabola. Okay, so that's something you're going to draw your parabola through. Once you find your vertex, then I would say let's find a point either above and below. In the case of a parabola opening to the right, or find a point left and right. Okay, so either above and below or left and right. So, yeah, kind of like I just drew there. P1 and P2 just stand for the 2 points that we're finding. So because we're dealing with something that's squared, a lot of times when we plug in a number, we might try to plug in something that has a nice square root. Because if we were going to solve this for y, we would have to take a square root of each side. So having a number that we could plug in that comes out without a decimal, that's going to make it easier to graph. Okay, so let's see if we can graph this. It says find an equation and graph. Okay, so we've only looked at one equation so far. When you're doing a parabola, the first thing you're going to have to decide is what equation do I need? With a parabola, you always have one variable that is squared, one variable that's not, and a 4. The different versions of a parabola basically look like this. That's one. That's another one. That's a third one. And that's the fourth one. Those are the 4 different formats of a parabola. One variable squared, one variable that's not, and you either have a 4 or a negative 4. That controls whether the parabola is going to open up, down, left, or right. That's one of each. I'm going to show you each one, so you don't have to write them all yet. But the way that I remember which equation does what is I look at the number, and then I look at that letter. That's a positive number. That's an x. Positive x means the parabola opens in the positive x direction. Negative number, x. That means the parabola is going to open in the negative x direction. Positive number, y value. That means the parabola is going to open in the positive y direction. Negative number, y value. Negative y means it's going to open down. So that's the 4 different kinds of equations you can have. Okay, but for now, the only one we're working with is opening to the right. So y squared equals 4ax. Okay, first step, you have to figure out what a is. They've given you enough information there that you should be able to figure out a. What's a going to be in this case? Yeah?
3.
3. Okay. A is always the number right here in this kind of equation. Now, in general, the a might not always be the first coordinate. If we draw the parabola in a different direction, the a might be the y coordinate. So the way to remember what a is it's the distance between the vertex and the focus. Just think of it that way. A is the distance between the vertex and the focus. Then no matter which way the parabola is opening, you can always figure out what a is. All right, so a is 3. When you're writing the equation, that's all you have to fill in. Leave the x, leave the y, but fill in 3 for a. That's the equation. Now, let me show you different ways you could see that if it was a multiple choice question, you could see something like, you could say solve that equation for y. That's the same thing. All I've done now is solve the equation for y. The only reason I would solve it for y is if I was trying to type it in on the calculator, then I could get the graph. And I'll graph this one on the calculator. All right. What's one point that we definitely know is on the parabola? Yep.
0, 0.
0, 0. They tell us it goes right through the origin. Okay, so let's do that one. So kind of making a table. We've got 0, 0. What would be another good x value to pick? I'd like to pick an x value that would result in a nice answer. Yeah?
3.
3. Yep, 3 is a great point to pick. Because if we plug in 3, what do you get for y when you plug in 3 for x?
6.
Positive and negative 6. What does that tell you right now about this graph that I'm about to draw? That second line in that table. Have an input value with 2 outputs. Yeah?
It's not a
It's
function.
not a function. Okay, so we're not necessarily drawing functions. We can draw things that are not functions. And a parabola on its side is not a function. Right, so I think that's pretty good. So we got 0, 0, we got 3, 6, and we got 3, negative 6. That's where the symmetry comes from. It's taking a square root with the positive and the negative. Now just make your sketch. Kind of like that. Kind of like that. That's good enough. Okay, let's check it on the calculator. Now remember, I can't draw things that are not functions. So all I can do is draw 2 separate graphs and just kind of stick them together. So let's go with function, y equals, and we got to type in the square root of 12x. Oops. Square root of 12x. And the negative square root of 12x. Okay, I'll do zoom 6 because I think my window is that I have over on the right is fine. And there's your parabola. What would be the equation of the directrix? Yeah. Yeah. The distance between, I didn't draw this point, but the focus was 3, 0. The distance between that purple dot and the vertex has to equal the distance between the vertex and this black line. Okay, so that's 3 units to the right. The directrix would go right there. X equals negative 3. Hey, and is that something I might ask for? Yeah. I might ask you to describe the directrix. Okay. Any questions on that? All right. Let's try this one. So this one's a little different. This time I'm giving you the equation, and I want you to tell me all about the parabola. I want you to tell me the vertex, the focus, which way it opens. Your options are up, down, left, right. And I'd like the equation of the directrix. Okay. First thing you have to do is rewrite that equation in this format. Because until we do that, we don't have A clearly written. It's like we have this. A's been multiplied out. We need to change it back to that. How would we rewrite the 8x so it looks like 4ax? 4 times 2x. Now, if you know what you're looking for, you know a is a certain number. What's a in this case? Yep, 2. A is 2. That's the whole key with a parabola. You've got to find a. Yes?
What if it was 2 times 4 though? Then 4 would be a? Like if it was flipped?
Well, the 4, there's always a 4 in every equation of a parabola. So you got to figure out what the number next to the 4 would be. I mean, it could be a 1, 4 times 1x. But you got to have a form to be able to see a. And that means it could be a fraction. Like if that was y squared equals 5x, well now you got to have something like whatever you would need in the middle. Oops. Whatever you would need there, if that was the original problem, you'd need a fraction now, like 5/4. So a would be 5/4. Okay, so looking at that equation, where is my vertex? Yep.
0, 0.
It's at 0, 0. Any equation that has one of those 4 formats that I showed you earlier, these are all equations at the origin. You'll know when it's not at the origin because it's going to have a shift in it. What do I mean by a shift? I mean something like this. That's a shift. It still has the same basic format where one letter is squared, one letter isn't. There's a 4, but now there's a -2 and a +3. That's going to shift the parabola. When you don't have a number added or subtracted to the x or the y, it's at the origin. Okay, so vertex at the origin. Where is my, let's figure out which way it opens first. Which way is this parabola going to open? Yep, to the right. You look at 2 things to figure that out. Is this positive or negative? And what letter is right there? Positive number x. Positive x means it opens to the right. Figuring out that direction right after you figure out your vertex is important because now you can figure out your focus. We know the focus is 2 units away from the vertex, but if you don't know the direction it opens, you don't know is it 2 units up, down, left, or right. Now you know it opens right. So the focus is 2 units right of the vertex. So where would that put the coordinate of the focus? Yeah?
2, 0.
That's 2, 0. Again, without knowing that direction, you'd have traces of 2, 0, -2, 0, 0, 2, 0, -2. Which way? Well, we know it's right. And if it opens right, we know the directrix is to the left. Kind of like this picture. What's going to be the equation of my directrix? Yeah? Great. Again, without knowing the direction, the 4 choices you would have, x equals -2, x equals +2, y equals -2, y equals +2. Okay. You have to make sure that your parabola always bends away from the directrix. Okay. So for a parabola opening left or right, that means it has to be vertical. For a parabola opening up or down, that means your directrix has to be horizontal. So it's very similar for every kind of parabola. Any questions on that one? All right, so this, very similar to the last one. They want us to discuss it and draw a picture. Okay. First 2 things I always figure out, vertex and the direction it opens. Regardless of the information that they write, I always do those 2 first. what's the vertex of that parabola? Yep.
Oh, 0,
0, 0. Yeah, when it's shifted, you'll know it's shifted. I'll show you one that looks shifted. A shift looks something like this. It's got to add or subtract to the x and the y. Okay. I don't even memorize all these other things because as long as I really understand what's happening, I can just look at it and think it through. Otherwise, trying to remember all these different formulas, that's complicated, right? All right, so we know it's going to open, vertex at the origin. Which way is this one going to open? And to answer that, you might want to rewrite this equation. How would we rewrite that right-hand side so it looks more in the standard format that we're using? Yeah.
4 times -3 y.
And what did we say about A?
Wait, oh, it can't be negative.
A can't be negative. A is measuring a distance. So if you want a negative on the right side, it's got to go with the
-4.
It's got to go with the 4. Yep. A is never negative. So now we've got a negative value, and we've got a y. Which way is this parabola going to open? Negative y. Yep, down. So now the next thing we can figure out is A. Since we've rewritten our equation, we've made A stand out. What's the A value for this equation? Lens?
8 equals 3.
Yep, A equals 3. So now we know A is 3. So what would be the coordinate of my focus, knowing that it's 3 units away from the vertex and it's in a downward direction? Yep.
0, -3.
Focus is 0, -3. So let's graph that. That's what the parabola is going to wrap around. And what about the equation of my directrix? This is what the parabola is going to bend away from.
0.
So equation, we got to have an equal sign.
X equals
Y equals 3. That's my directrix. Okay, let's get some points. Vertex, we already know. 0, 0. And this time, what I would do is kind of think of it like we did the last problem. Let's get rid of that x squared, and let's take the square root of each side. So we get x equals the positive or negative square root of 12y. So now we're going to make a table of values, but you're going to pick a y value and solve for x, because that's how this parabola is oriented. What would be a good value we could plug in for y? Yep. -3, perfect. We definitely don't want to plug in positive values for y. Okay, if we plug in positive values for y, we're going to have the square root of a negative number. That's imaginary. So this graph is not going to have any positive y values on it. Okay, we need negative y values. So -3. And what do you get for x if you plug in -3 for y? plus or minus 6. Now, that's perfectly fine. You have, if I wanted to write it as separate rows in the table, it would be like 6, negative 3, negative 6. That's still a function. You can have two different input values going to the same output value. That just means it fails the horizontal line test, which means it's not invertible, meaning you can't find the inverse of it. But we don't care about that. Okay. So let's graph it. So 6, 1, 2, 3, 4, 5, 6, negative 3, and 1, 2, 3, 4, 5, 6, negative 3. Okay, make sure your points look symmetrical. And then do your switch. Yeah, let's graph that. And this is something we can graph. Right? The calculator should be able to graph that because it is a function. Okay. What letter do I need to solve it for if I want to graph it? I got a calculator. What do I have to do to be able to put that in? Yeah.
Put the y by itself.
Get the y by itself. So all I have to do is divide each side by negative 12. So that's another way you could see this answer written on a test. X squared divided by negative 12 equals y. Let's graph it and see if it looks just like that. Yeah, that's it. If you want to double check your points, you could trace to 6. You see you get the point 6, negative 3. And now trace to negative 6, negative 6, negative 3. That's exactly what we got. So any questions on finding those characteristics or doing the graph? Yes?
How come the focus is a negative 3 for the positive 3?
Because the parabola opens down, and if the focus was a positive 3, then the focus would be up here, and the parabola wouldn't wrap around it. Okay, think of that as like the point inside the satellite dish. The dish has to wrap around the focus. That's why we always find the direction that it opens first and the vertex, and then you can figure out everything because you know which way the parabola is facing. All right, so this one says you have to find the equation of a parabola that has a focus at 0, 4 and a directrix at y equals negative 4. Okay, that is enough information that you should be able to tell which way it is going to open. And that's the key to finding the equation. Which way is this parabola going to open? Yeah, it has to open up. The directrix alone tells you that. Okay? It has to bend away from the directrix. The directrix is down here. There's only one way that a parabola could open and be bending away from that and never touch it, and that would be up. Okay. So your directrix is at negative 4, and the focus is at positive 4. Now, they didn't tell us this, but where does the vertex have to be? Yeah? It has to be exactly in between the two. So if you know that the directrix is 4 units down, the vertex is 4 up, even though they didn't say this, focus is 4 up, the directrix is 4 down, the vertex is right in the middle. So vertex has to be 0, 0, which is good, because that means it's the simpler kind of equation. We haven't done any shifting yet. Okay. What's the general form? You don't have to fill anything in yet. It's just the general form of an equation where the parabola opens up. Looking for something squared equals 4 something something. X squared equals 4ay. Maybe I wrote them down, but I don't think I labeled them. Maybe I should label them all. That's up, and that's the one we want for this problem. X squared equals negative 4ay. That's down. We don't want that one. Y squared equals 4ax. That's positive x, that's right. And y squared equals negative 4ax. That's negative x, that one's left. Again, that's the one that we want. Okay. The last thing that we need to be able to use that equation is we need to fill in an a value. What is my a value in this problem? Yeah.
Negative 4.
No. Not negative 4. Yeah?
0.
No, we can never have an a value of 0 because then it would wipe out the right-hand side completely, and we wouldn't have a parabola anymore.
4.
4, yes. So the a value is 4, is the distance between the vertex and the directrix, or think of it as the vertex and the focus. But yeah, 4. So now you're basically filling that number in for a, and that's going to give you x squared equals 16y. Could see that rewritten as x squared over 16 equals y. That would be a common way to write it if you solve it for y. Or you could also do 1/16 x squared. You could write it as a fraction. Any question? Did we do everything? Find the equation. We already sketched one earlier, so I'm not going to sketch this one again. It would be opening up. Okay, let's try this one. It says, find an equation of the parabola that goes through the vertex. The axis of symmetry is the x-axis, and it contains the point -1/2, 2. Okay, so I graphed the vertex, and I graphed the point -1/2, 2. What do we know about the parabola from that information? Yeah.
It opens up to the left.
It opens which way?
Up to the left.
Well, the 4 choices are up, down, left, or right. So it can't open up to the left.
Oh, well, sorry, it contains 1/2, too. Sorry. But it does open up. Or left.
We definitely know which way it has to open on that, based on that. It can only be one of the things you just said. Yeah?
Opens up to the left.
It opens to the left. Why does it have to open left?
Because there's a negative x value.
Okay, so we do have a negative x value. Also, the axis of symmetry is horizontal. There's no way, if this is your axis of symmetry, you know that this point is going to be mirrored down here. So it has to do something like that. Okay, so it has to open left. Now that tells you the format of your equation. So it opens left. What's the format of a parabola where the vertex is at the origin and it opens left? Yep.
Y squared equals -4x.
Yep. Y squared equals -4ax. Now we know at least the type of equation we need to plug into. Now we need to figure out the A value. Did they give me the focus? Lance?
No.
No. Did they give me the directrix? No. So A is the distance between the focus and the vertex, or the vertex and the directrix. I don't know the focus or the directrix. How am I going to figure out A? Yep.
Could you plug in the point that you want to have into the table?
Yep. I'm going to plug in that point that they gave us. We know a specific x and we know a specific y. This is just kind of like y equals mx plus b, where you're trying to solve for b. You know enough information, you plug in what you have, and you find what you don't. So plug in 2 for y. And then we're going to plug in -4. We're going to leave that. A we're going to leave because we don't know. And x is -0.5. So we're going to get 4 equals 2a, which means a is 2. Now, if we wanted to find the focus and the directrix, we could. We know the focus is going to be 2 units to the left of the origin. The directrix is going to be a vertical line 2 units to the right. They didn't ask for that, though. They just asked for the equation. So fill that in. Y squared equals -8x. And that's the equation of the parabola that fits the conditions they wanted it to. Okay, any question on that? All right, so now this is that chart, which you can write it all down if you want, but it's a lot to write down. So the only difference between the equations here and the ones that we've been working with is now we have an h and a k. The h and the k value is going to be the coordinate of the vertex. A is always a positive value. It can never be 0 or a negative. The right-hand side will tell you the way that it's going to open. Just look at -y opens down, positive y up, -x left, positive x right. And if you can figure out which way it's going to open, you don't have to think about, okay, I know it opens right, so that means I need to add something to the horizontal to move the vertex to the right. You don't even have to think about it all. We can just draw a picture, and all these formulas will just automatically make sense if we really understand what's happening. So just know that the vertex is h, comma, k. And you're filling them into one of those 4 formulas. A is still the distance from the focus to the vertex, or the distance from the vertex to the directrix. Take that. Axis of symmetry, it's always parallel to one of the axes, either the x or the y. If a parabola opens left or right, axis of symmetry is always horizontal. If a parabola opens up or down, axis of symmetry is always vertical. Okay, let's try it out. So it says find an equation of the parabola where the vertex is -2, 3, and the focus is 0, 3. Those are the 3 letters you have to find, and then you have to figure out which one of those 4 formulas you fill them into. Let's figure out our formula first. Sketch those 2 points, and it should make it very clear whether the parabola opens up, down, left, or right. Your focus is up 3. your vertex is left 2 and up 3. Negative 2, 3. Vertex. Which way does this parabola have to open? Yeah.
To the right.
Yeah, it's got to open to the right because it has to wrap around the focus. So what we need is the formula that faces to the right. All right, so let's think about that. Well, they all have a 4A. And if we're going to open to the right, that means we want positive 4. So it could be a positive or it could be a negative 4. So I take that back. It's not always positive 4. But this one is positive 4, and it's on the x direction. We want it to open towards the positive x. So that means this is the y squared. Now, the only thing we have to do is adjust it for the vertex. Y minus k, x minus h. K is the y value of the vertex. The k always goes with the y in parentheses. Whether it's on this side, the y is with the k, or it's on this side. X always goes with h. H is the x value of your vertex. So x always goes with h. X is with h, x is with h, x is with h, x is with h. You can't switch those. X with h, y with k. All right, so we've got, let's check it, x with h, yep, y with k, that looks good. Positive 4 with an x means it's going to open right, and we always want the variable on the left side squared. And that's it, that's your formula. So now just fill in everything that we need to. What's going to be my h value in this problem? Yeah.
-2.
H is negative 2. Yep. How about my k value? Yeah. Right. Yep. K value is 3. H and K are usually the easiest ones because they're given to you directly if they tell you the vertex, you know them. And then what about my A value? What's that going to be? What? 2? And how'd you get that?
I just assumed that the distance between the vertex and focus.
Right, A is always the distance between the vertex and the focus. And if you find the distance between those 2 points, then you have a distance of 2. Yep. Okay, so you got everything you need. Now we just fill it all in. So the equation is y minus 3 squared equals, fill in 2 for A, 4 times 2 is 8x. Now we got to be careful with that because when we fill in the h, it's a negative, so it's x minus minus 2. So it becomes plus 2. And that is the equation of our parabola. Okay. If we wanted to graph it, we could distribute out the 8 on the right, take the square root, and then add the 3. Let's take that in and see if we get a parabola that looks like it's been shifted 2 units left and 3 units up and opens to the right. If we do, then we did it right. So you've got the square root of 8x plus 16 plus 3. And then I'm just going to do it like this. It's just faster for me to type. No, I can't do that because then it would do a negative 3 on the end. So much for my shortcut. So it's the square root of 8x plus 16, but the 3 is still positive. Okay, so let's hit zoom 6 and see if it looks something like that. It doesn't connect in the middle. There's nothing I can do about that. But that's what we wanted. Okay, any question on that? So in general, the way that you know a variable, or the way that you know an equation is a parabola. Because on the test, they're all going to be mixed together. So the first thing you're going to have to figure out before you start the problem, did he give me a parabola, a circle, an ellipse, or a hyperbola? Once you know it's a parabola, then you can start doing what we learned today. You'll know something is a parabola because one variable is squared, the other variable is not. When you start squaring both variables, then it's not a parabola anymore. Could be any of the other three. Squaring, if you know both variables are squared in the formula, that's not enough information to tell me if it's an ellipse, hyperbola, or a circle. I need to know more. But if both variables are squared, I definitely know it's not a parabola. That's all I would know. Okay. Any question on that? All right, so that's, I think, pretty much it for parabolas. So parabolas, just like all the other conics, sometimes I'll give you a sketch. I'll ask you to tell me about it. I'll tell you about it, and you give me a sketch. Or I'll give you some characteristics, and you give me an equation. Or I give you an equation, and you give me the different characteristics. Those are what all the problems are going to be like today, tomorrow, and Wednesday. Very, very similar lessons all 3 days. The only thing that makes this a little tough is once you learn all the conics, then it's easy to start mixing things up. Right now, you might, you've got parabolas and you got it all straight. The other conics adds more to it, so then you have to keep everything kind of organized. Okay, so the homework on 386, 11 to 18, that's matching, and that's all. 19 to 31, just the odds, and 37 to 43 is odd, and then 55 and 58.